Our next speaker is Dr. Anna Cates. She's going to be talking about strip till and cover crops and how sugar beets fit into the whole thing. So here you go.
Thank you. Can you help me find my presentation here?
It's already up there. Just hit the.
Oh, so it is. That's a
You just
shook.
hit that for your next slide.
That's a shook there.
Oh, that's a sugar.
Yeah. Here we are. Oh, I wrecked it. I'll give it a sec.
There we go. Does that look right?
I think it's happening.
You got it?
Yep.
Okay. Yeah. If it doesn't work, I'll forward you.
Okay, thanks. Hi, everybody. I'm Anna Cates. I'm a soil scientist working out of the St. Paul campus. I'm the state soil health specialist. I have a slide that just shows some pictures of what I've been doing. I wanted to just introduce myself since I don't talk to this group all the time. I've been in the state about 5 years. I'm coming out of degrees in soil science and agronomy from UW-Madison. I got interested in soils after living on a cow-calf operation with my parents as a little kid and working on small vegetable farms. But most of my research is around soil organic matter and soil structure in different systems. One thing you sometimes see after my name is the Minnesota Office for Soil Health, which is a statewide office that tries to promote adoption of soil health practices. So I like to define soil health to start out because it is not always obvious what people mean by that, or people could mean a lot of different things, which for the most part I think is fine. The NRCS definition of soil health is the ability of soil to function as a vital living ecosystem. So I focus on that word function. Your soil health is related to your soil function. This flow chart is kind of a cheeky way of getting at that, asking if you have certain functions. If you do, soil's probably healthy. If you don't, soil's probably not healthy. You can see I stole this from our friends across the border, Kaylee Gash, as well as extension educator in Washington, Andy McGuire, who you might know if you're active on Twitter. He tends to be pretty active there. So I circled some of the functions that I thought we were especially concerned about in beet cropping systems, which are soil blowing and flowing away. This is often a complaint we get in a system which requires a lot of tillage and soil disturbance. And then this question of whether there are areas where plants die or grow poorly. That last one is to point out that not just your soil microbes or your soil structure are indicators of soil health, but your plants themselves can indicate whether your soil is healthy or not. If your plants aren't thriving, you could say your soil is probably not healthy. So most of the data I'm going to show today is going to be about how sugar beets fared in systems that incorporated what I think of as soil health practices, specifically strip till and cover crops. I have a unique goal with this presentation, which is to show you a number of very, very boring data sets. Because my take-home point is that we didn't see a lot of differences in beet yield or quality when we use these practices. So they should be fairly equivalent in most production systems, with the exception that there's a lot of logistics in terms of adopting a new system. So acknowledging all that, my goal is just to show you some boring data that these practices can produce equivalent yield outcomes. The first few sets of data I'm going to show are actually from a grad student at NDSU that Tom Peters advises. His name is Aaron Hoppy, and he's had some on-farm trials comparing strip till and conventional till for a few years. So in this case, the darker bars are conventional till, the red bars are strip till, and each one of these is a location, with the furthest right bars being the combined data. And you can see in this case, their root yield across the board is really similar. You know, it varies from place to place, but there's no place that there's a significant difference in yield. The next one should be the same area, but with the percent sucrose and recoverable sucrose. Again, pretty boring data. There were no differences whether we had strip tilled or conventionally tilled systems. These were in farmers' field with some side-by-side plots. We had replication where we could do it, but the main replication is from site to site across northwest and central Minnesota. A big issue that people are concerned about with a system with less tillage is whether the soil will warm up sufficiently in the spring. I would argue that the proof is in the pudding in terms of the outcome for the plant, and we are showing that the crop outcome is similar. But Aaron did do some measurements of 4 centimeter soil temperature, so 4 centimeter, just a couple inches down in that seed zone. He wasn't able to do this everywhere, so we don't have it everywhere. But this shows the conventional till in blue, the strip till furrow, so the seed bed in red, and then between the strip till furrows in yellow. And you can see that and the left to right axis is the hour of the day, so starting at midnight, and then the highest temperatures being in the afternoon of the day. You can see that yellow area, which is between the strips, so essentially where you have no tillage and more residue, is a little cooler. So we are seeing cooler temperatures there, and a little bit cooler in the furrow itself, especially towards the end of the day. In the afternoon, they're comparable. This is another set of temperature data which shows a less of a difference. So in some sites we saw that drag in temperature, and in this site we didn't. This is a little bit of a heavier soil, so it's actually getting a little bit less fluctuation in general. And that's our presumption that in a heavier soil you're going to see less of that temperature fluctuation regardless of your tillage. This is just another way of looking at that data where you can see several locations, and in this case they added up what they call the heat units in the soil, so just a way of indexing the total amount of temperature over the course of 30 days. And you can see that in some cases, if you compare the conventional tillage furrows versus the strip tills, you do have a lag in that strip till system. Again, we weren't seeing an outcome or a difference in yield. So that's the data I'm presenting from Aaron Hoppe, a bunch of on-farm trials. I'm going to show a few more on-farm trials and then some research station trials that show similar stuff. So this is from a paper that I think should come out in the Journal of Sugar Beet Research shortly that I worked with Jody DeYoung-Hughes on in 2021. These were on-farm trials where we compared strip till systems with and without cover crops. So the conventional chisel plow system is in orange. Strip till with no cover crop is forest green. Strip till with an early cover crop, meaning a cover crop planted early in the season before, so presumably with more time to grow, is the light turquoise. And then the other blue color is strip till plus a late cover crop. Again, we saw no differences in yield except for between sites. I will say that our cover crops didn't grow very well in this case. It's hard to establish a cover crop after corn in Minnesota, as maybe some of you know, and we weren't especially successful in this particular year. So we have been doing some more trials. This is funded by an ongoing funded project that I'm working on. And we're looking at both pre-beet cover crops in on-farm trials and Crookston trials at the Research and Outreach Center, and then some cover crops interseeded in beets. I have a picture of my graduate student who's been working on this there. He put all this data together and has been working hard to try to understand these systems as best we can. The QR code should take you to a data report, which is also linked from the little flyer up at the table up front. So if you want to look at this data in particular, you can. So what we're doing in these experiments for the pre-beet cover crops, this is pretty straightforward. We're essentially comparing a fall-seeded cover crop, which we think will give us more benefit in terms of having the soil covered over the winter or slowing any winter and spring erosion, to the spring-seeded cover crop, which is pretty common practice, that barley seeded alongside a sugar beet planting. So are you going to get any more benefit or any detriment to the fall-seeded versus the spring-seeded cover crop? These were done in Polk and Wilkin County, and we had a little difference in the harvest treatment there. The other thing we did was the interseeded cover crop treatment, and we did this just at the Northwest Research and Outreach Center because I think David has presented results on this before from their research plots. It's a relatively risky practice. In this case, we have 2 years of data. We planted beets in May of 2022 and 2023, and we drilled the cover crops just prior to canopy closure and after our last herbicide pass there, and you can see them in there. We drilled rye on the left and mustard on the right. And then we did harvest in the pre-pile time period for this. So these figures I'm going to show from this research project will have both sugar and yield on the same slides, and these are from our Northwest rock plots where we really had terrible stands and pretty unimpressive yields. It's not great when you see the sugar contents and the yield so close to each other numerically. But the take-home point was that the cover crops themselves didn't affect the yields at all. At the Wilkin County site, we also saw the same thing. In this case, we just have the rye and the barley as our two treatments, whereas, I'm sorry I didn't explain this, at the Northwest Research and Outreach Center, we had a few different cover crops that we planted in the fall beforehand. It didn't make any difference what cover crops we had there. On the Polk County site, we have more respectable yields here thanks to our good practices of our farmers. We did lose a couple of replicates here, so if you're wondering why those bars are so flat, it's because we lost some replicates due to in-field issues. But we did have good yields and good sugar content across the board. If anything, on that Polk County site, you might see a little dip in the yield and sugar with the control, but we aren't going to probably trust that until we have some more years of data because we just didn't have the replication we wanted. In our interseeded cover crops, again, we had interseeded rye and interseeded mustard compared to a control. They didn't affect the yield, but they also didn't survive the season. So I just don't love this system. It seems like it would be a good time to get a cover crop in there, but as you all know, the practices in the field tend to be too destructive to let it stay. In talking to growers who have been experimenting with these systems, what I hear is that looking at a cover crop seeded towards the end of the beet season might be more effective. We have some trials going on up in Polk County right now on farm where we're looking at aerial seeding a cover crop around the time of just before defoliation so that the harvest activity itself could incorporate the seed to some extent and it'd be ready to go should we get the heat units in the fall. With cover crops, a lot of it has to do with those heat units in the fall. The other benefits we're going to be looking at here, I'm not going to share any data on this today, are erosion specifically. We have some wind erosion devices where we're actually collecting the sediment blowing around on the landscape. We're also looking at infiltration. So that device on the right is an infiltrometer that rains on the surface of the soil, and then we collect the runoff through that little tube coming out the bottom. So we'll see if we can see any differences in infiltration that could be created by the activity of the cover crop roots in the soil. And then we're looking at some soil biological activity and organic matter. I have, like I said, a flyer out front that talks about these other dates that we're going to have where we're going to talk more about this. We've got panels of farmers in each of these locations who will talk more about their experiences with this. I guess I feel like my role here is just to show the data saying that we're not seeing a big effect of this, but we know there's a lot of issues in terms of actually applying these systems. And I'm hosting these meetings alongside the soil and water conservation districts and the companies who have been really supportive as I've learned about these systems, and we've brainstormed different ways to incorporate more conservation practices into them. So I have a little time here, and I can take a couple questions about the data I showed, if there are any questions about no differences, or else I might talk just a little bit about why these practices might have an effect and the soil structure we like to see in these systems. Any questions, though? Yeah. Yeah, so some of our aerial seeding work where or you could broadcast it also if you have you could broadcast it with that defoliation pass perhaps. I think that window is going to be more effective than that early window at this point, but that's totally based on talking and listening with folks and less on any research data that we have so far. The other thing I'll say is that cover crops are often really successful on those pre-pile strips, and the way we're thinking about erosion in these landscapes is whether we can slow down the sediment movement enough with just the cover crops on the pre-pile strips. You know, that's how wind breaks work, right? They're just a strip across the land. You don't have to have trees everywhere as long as you're slowing the wind down somewhere. And some cover crops can do that to, to a shorter extent. Yeah.
Data. I would say more of the concern for growers is soil temp, April, May.
Yeah.
In your June, July study.
Yeah.
For future research.
Yeah, that's a good thought. The earlier temperature is obviously the bigger concern because that's the time that the seed needs warmer temperatures, and I suspect that the thermometers went out at that time simply because of trying to stay out of growers' way as they're doing field prep and getting ready for the year. Is that? Yeah.
The other thing is, Anna, is there was field operations going on.
Yeah.
So we wanted to not run over it.
Yeah, those temperature sensors are more expensive than a kid's thermometer. But I agree, that is the critical window.
Good feedback.
Yeah. Okay. All right, I'll just take a couple more minutes to talk about this. So I don't know if you've seen these soil health principles out there. This is stuff the NRCS promotes: keeping the soil covered, reducing disturbance, increasing diversity, keeping a root in the ground, and integrating livestock. The critical one here, I think, is keeping a root in the ground. The more you have a root in the ground, the more you automatically do those other practices of reducing disturbance and having more crop diversity. And this is why that kind of works. So we have this food web underground where plants are feeding microbes, which are feeding larger organisms. And you just heard a lot from Ashok about some of the negative results of having a lot of organisms in your soil. But you have millions of organisms in your soil, and lots of them are providing really important functions, especially in regards to nutrient cycling. But the other function they provide has to do with the physical organization of your soil. So you can't change how much sand, silt, or clay you have, right? That's something you're born with, right? Like, we can't really change how tall we are, we just wear different shoes, right? But your soil is gonna have that sand, silt, and clay, but your management can change the actual structure and the organization of those sand, silt, and clay particles. So as microbes live in the soil and die, their cells actually form glues around the mineral particles. So these little cartoons are meant to show organic matter and microbes themselves living right on the surfaces of those particles. And they especially live on the smaller particles, the silt and the clay that you have there. And so, I don't know if this one will play, but we can try it. So when you have those particles coming together as an aggregate, then you have a mixture of pores, organic matter, and minerals, all in kind of a heterogeneous arrangement. I'm going to switch to this cartoon since my video doesn't play. So that picture on the right is a cartoon depicting the inside of an aggregate, where you have pockets with lots of organic matter, pockets with bigger pores, pockets with smaller pores, and it's all held together with both those microbial glues and then the stringy bits of roots and the fungal hyphae. So those organisms are holding the soil structure together. And what we do to support those organisms, like giving them a food source in terms of residue, and simply not disturbing them in terms of low tillage regimes, that's how you get more structure in your soil. So the structure on the right represents kind of the microscopic level, where you're actually looking at fungal hyphae and microbial cells. And then the structure on the left represents what you're going to see in your hand in the field, where you see roots and things that are obviously going to be vulnerable to tillage passes through the field. So to get at the function of that structure, I'll just show a couple of pictures here, where on the left you have a poorly aggregated soil with a really smooth surface. And on the right, you have a well-aggregated soil with lots of different sizes of particles, right? And on the left, in the bottom part, what you see is water trying to enter into that soil. It's a cutaway image. And so the water is trying to get between these tiny particles, and it can't get very far in. On the right, where you have bigger particles, you can have more bigger spaces for the water to get in. Where the particles are bigger, the pores are bigger. But when you think about the functions you want from your soil, you actually want two really different functions where it comes to water. You want that water to enter through big pores, and you want it to stick around in small pores. And you really only get that when you build structure. Sand naturally is going to give you those bigger pores, and clay naturally is going to give you those smaller pores. But by building structure, which is your aggregates, which are glued together by organic matter, then you can get some of both. So here I have little dots added to the picture to show the small pores inside the aggregates, as well as the big pores around the aggregates. And when you look at that in the field, this is again after we've used that infiltrometer device where we rain a little bit through tiny tubes onto the soil. On the left, you have a soil which didn't have a lot of structure because it had been tilled a lot. It doesn't have a lot of roots in the ground. And it turns into this jello. The aggregates in the system just dissolve. There's no more big pores to carry water through, and it's not going to hold any water either because it's not well structured enough for water to enter all the pores it needs to. On the right, you have a soil where this is after a rye crop on our research farm in St. Paul. So it had a full year of roots growing in the ground. And you can see there's still big cracks where water can get through, and in between there's still those small pores where water can be stored. So these are the functions we want from a healthy soil. We support our biology in order to get certain functions. You could make the same argument perhaps about nutrient delivery functions, but I think these water holding and water moving functions can be of real immediate effect on different farm fields. So I will stop there. Maybe I have time for another question, or maybe we just head right back to the cinnamon rolls.
Any questions for Anna? All right, thank you, Anna.
Thank you.